So I want to go ahead and kick off the live stream now while we wait for folks to join. Today's webinar is going to be all about the AP Computer Science Principles Create task. For those of you who are new to AP CSP, maybe aren't so familiar with the Create task, I'll provide a little bit of background on that. So the introduction of the AP CS Principles in 2016 was the largest course launch in AP program history. In 2019, nearly 100,000 students took the AP CSP exam, which is more than double the number of exam takers in the course's first year. So in the 3 years since the course launch, the number of female AP CSP students has far outpaced overall growth, with an increase of 136%. So the AP CS Principles program introduces students to the foundational concepts of the field and challenges them to explore how computing and technology impact the world, which is somewhat divergent from AP CSA, but also bears some similarities. First of all, AP CSP is language agnostic as opposed to CSA, and the test measures computational thinking skills with pseudocode as opposed to AP CSA that uses Java and focuses a lot on object-oriented programming skills. AP CSP is also unique in the fact that it has this portfolio component where students work on a performance task, which is a student-developed program of their choice where certain programming skills must be demonstrated, and that's what we're going to be talking about on today's live stream. I'm joined today by Joe Mazzone and Becky Fisher. Thank you all for joining us today. Becky Fisher, do you mind introducing yourself first?
Hi, I am Becky Fisher. I am at Politics STEM High School in Norcross, Georgia. It's just east of Atlanta, like 30 minutes east of Atlanta. This is my 14th year teaching. I've taught math for 11 years, and this is my 3rd year doing computer science full-time, but my background, my bachelor's was in computer information systems, and I actually was a programmer for 5 years back in late 90s, early 2000s before I became a stay-at-home mom. So I've been eager to get back into computer science, and it's been a real hard push to get it into schools. So I was excited to come to this STEM school because I was out in a rural school before, and I just couldn't get kids to sign up to take it. So definitely needs to be put in more schools out there. The lights just went out. That's me.
Any teacher knows that experience with the lights going out.
Awesome. Great to have you, Becky. And the topic of comp sci in rural schools might be something for a quick chat at the end here, maybe. Joe?
Hi, I'm Joe Mazzone, and I teach at Davies Curran Technical High School in Lincoln, Rhode Island, which is just north of Providence, Rhode Island. And I teach at a specialized school also for career and technical education. I teach in the pre-engineering program, all the computer science coursework for that program.
Awesome, awesome. So I'll pass it over to you, Joe, and let's get started with AP CSP Performance Task.
Yeah, so first, for those that AP Computer Science Principles is new, you may be curious about what is this performance task component. So unique and similar more to some of the AP art courses, there's a portfolio component for AP Computer Science Principles where students have to create a program, have to demonstrate their skills, and submit that to be evaluated by AP readers. This is different from, let's say, the free response questions on the AP Computer Science A exam, where a day of the exam, the students have to complete those tasks. This is something that's completed ahead of time and submitted as a portfolio entry for the student. So it's really unique, really cool, and it actually makes a lot of sense for a computer science course. So it's something I've really enjoyed. But mainly, there's been some changes, and so let me kind of screen share what you have to kind of do as part of this task. And so there are a couple different components to it. So of course, students develop program code of their own But there are some other points that they have to hit, and I'm sure Becky and I are going to dig a little bit deeper into these as our kind of talk goes on. But there needs to be some kind of input from the user, a device, a data stream, a file. So students have to have some kind of input into their program. They have to use some kind of collection data type. Most likely it's going to be a list or an array, depending on the language that you're using. It needs to have at least one procedure. And that procedure has to have one or more parameters. You need to have an algorithm that includes sequence, selection, and iteration. So they have to demonstrate conditional statements as well as loops or repetition. They have to call their student-developed procedure. And then they have to have some kind of output. Or their program has to produce something and do something. And I would say those are the main components. And if we were to scroll down a little bit more, it would be a little bit more detailed, and we'll look at that in a little bit. But Becky, would you add anything else that's an emphasis of just looking at it from a general overview, the task?
Well, about the procedure, make sure to emphasize it has to be a student-developed procedure.
Yes.
I am finding some that are not.
Mm-hmm. This is the procedure here is going to be, I think, when we dig a little bit deeper in a minute, what Becky and I are going to talk most about. And all of the conversations in the different Facebook groups and stuff have really been around the requirements related to this. I'm seeing even on some groups, teachers that I know are very experienced teachers are now questioning some things. I think as their students are completing the task, they're re-looking at the rubric and questioning things. And so for me, when College Board first released this, at first glance, I was like, oh, this is very straightforward. And then later, actually, as the school year went on and I started to revisit it, I started to question more things involved with the rubric and seeing that this wasn't as easy to do necessarily. But it was interesting. Becky, would you like to talk to people about how this, what we just kind of overviewed is different from last year when we talk about the portfolio and the performance tasks, just for people that are new to computer science principles?
Well, I know that in the past few years that it was out, there was a lot more creativity that my students were able to use to they could make all these games and everything. And then when this year they required that they use a list, at first I felt like it was very limiting to the possibilities as to what we could do because of having to use a list. And as I start seeing more and more examples that people have been posting and things that are out there, I'm realizing that there are ways to use lists to create some cool games, because I kind of felt like it took all that fun game creation out of it. But the list requirement was a big change this year, and I realized that a little bit too late, because I don't feel like I really delved into how to use list in more ways than just what CodeHS is what I was using. I really feel like I should have given them more opportunities to explore different ways to use a list. That is one of my takeaways from this year that I wasn't prepared for.
I agree. So one of my notes is, for sure, I'm boosting my curriculum up a little bit about using lists, traversing lists, list algorithms that can help with many different things in different programs. I'm hoping to add a lot more to that to my curriculum and have this larger focus on lists, just so students think more about leveraging using lists to manage the complexity of their program, as the AP Create task would talk about. So certainly lists were covered previously in my curriculum and were covered this year, but I agree with you that your curriculum needs to have a much bigger focus. And I think a lot of the curriculum providers don't have a big enough focus as to really help with this task.
You were talking about the whole manage complexity. There's that one prompt in the written response where the students have to explain how using that list was helping to manage the complexity of their program. And that is a big thing that I feel like needs to be emphasized when you start learning about lists and understanding why you use lists, not just why you use that list. Like, you know, they're telling me, well, I use this list because it helped me create, you know, have a place to store my values. Well, it's more like, well, why did you do it that way instead of separate variables? And they're not, so many of my students are not explaining it as far as why was the choice of using a list able to help make your program less complex versus another way. They're really, really struggling with that prompt. So as we go into lists next year, I'm going to make sure that they understand more about why would you choose to use a list.
Yeah, so previously this task specifically, and I'm going to go back for those that, you know, don't have as much experience with computer science principles about what the portfolio entries looked like last year, or, you know, what was going on there. But there was this emphasis on abstraction, and students could kind of talk about a data abstraction or a procedural abstraction, or they could talk about abstraction in any way they wanted for their program as long as they were able to focus on that. And many of the curriculum, including my own developed one, focused very much on procedural abstraction, teaching students to break down their code into different procedures in order to more effectively structure their program, as well as reduce redundancy, things like that. And I think we got, as computer science principals kind of community, got really good at that. And then they threw this curveball at us with saying, no, your students have to do both. They have to have a list to kind of manage the complexity of their program, and they have to have procedures. So where I would say maybe over the past 3 years, 2 or maybe 5, I would say 5 students maybe talked about lists or something like that in the entries of the 20, 40, close to 100 or more than 100 students I've had take a PCSP. Only like 5 really talked about that. Everyone else always talked about procedures. So certainly a big change this year for that. So last year, there was actually 2 components. And so I'm curious about this on your end, Becky, because this has been a heated conversation also. So those that didn't know, maybe you're new to AP Computer Science Principles this year, and for you, Sasha, last year and since the inception of APCSP, there were actually a explore and a create task. So there are actually 2 portfolio entries. Now there's only this create task. And the explore task was like a research project where students got to look at some innovative technology in CS and learn about it, and then create, I'll call it an infographic. You know, they called it a computational artifact, a graphic about the thing, as well as complete this research outline about the technology, explaining the data issues involved with the technology. What were some of the other components, Becky? You remember some of the big talking points?
The positive and negative
impacts on society.
Effects, and yeah.
Yep.
It's about the data. Oh gosh. Concerns like with the data, whatever it was.
Yeah. So it was big on like harms and benefits, and the students weighing the harms and benefits of the technology. And so students were doing all kinds of things, blockchain and cryptocurrencies, and even just virtual reality technologies, augmented reality, all kinds of interesting things. And that's removed. You're supposed to kind of cover some of those topics so that students understand the innovation in computing. But that specific component to the portfolio is gone. Now they're just doing this programming task. And as Becky and I started to say, it's a much more detailed prompt. In College Board, as many would say, College Board did that because they felt like students were able to meet the requirements and score pretty highly with some not so sophisticated programs previously, with the way the create task rubric was. But so Becky, what I'll throw at you is, did you like that the explore task is gone? And you already started to talk about if you like this create performance task better or not. But if you could talk about that a little bit.
So the Explore task was definitely my least favorite part of the course. I felt like that.
Me too.
I mean, we were having to teach them how to do research and cite their sources, and even though it didn't have to be a specific way, they wanted it to, like, they wanted specific guidance on how to do it. And I really had to recruit my media center specialist to help me with some of the you know, citing and all that stuff, because that was just really not in my comfort zone. But I also even find that same issue with the create task, because a lot of the kids who do take this course are more, they're wanting to focus on the program, and they want to spend a lot of time creating a very complex program, and, you know, something that they think they're going to just like go put out there and sell tomorrow or something. I mean, and I have to repeatedly tell them every year, guys, this is not about creating the best program out there. It's about showing that you know these basic concepts, that you're going to be scored on how you can explain it. And so one thing that I do is, throughout, from the very beginning, there's a lot of writing prompts in the curriculum that I use. And in those writing prompts, I actually ask them to restate what it's being asked. Use proper grammar and full, you know, complete sentences, and restate what you're being asked, so that they don't give me these short phrases as their answers. And, you know, it's like the one thing about the prompt about how does the list help manage complexity. You know, I'm like, guys, you've already got part of your sentence started right there. You know, just go with what it says. My list helps manage the complexity of my program by doing blah, blah, blah. And, you know, because it looks like you know what you're talking about. It's not that, you know, you can't just throw that in there and think you're going to get the point, but it definitely looks more professional, and they think, okay, I'm going to take some time to read what this kid has. So I emphasize from the very first on the complete sentences, proper grammar, restating what they're being asked, because these kids are, they love the coding. They want to code, but then when it gets them to write it, they struggle, some of them. So, as far as, do I like this, I'm going to say that in the requirements, it felt very restricted. I felt, even myself, I was having trouble coming up with ideas for using a list in the beginning. And I felt like all my kids were going to be doing a lot of the same stuff, because it just didn't seem like there was as much to do. But the more I have explored other ways that use list, I have become a bigger fan of it, actually. There goes my lights again. I have become a bigger fan of it, because I do like that it does seem a little bit more focused in on, you know, the specifics of, this is a list, this is why we use a list. This is my procedure, and this is what's going on in my procedure. And I really think those are two things that are really hitting on, you know, with this task, that I think are very important for these kids to understand with coding. And also, because of having to use a list, that I don't think I focused so heavily on it before in years past, but I did a lot better job, you know, giving a lot of list examples this year with my students and principals, that I feel like it's going to be so much better when they take APCSA with me next year, because I feel like I've covered it.
My thoughts exactly too. My thoughts exactly also. And so, yeah, so I think you talked about this, and so the reason why my points for liking this year's task better than previous year's task is because it does force a focus. And I had an issue, especially the first year I taught APCSP, where I had students that were excellent computer programmers score lower on the task, because they made these awesome programs. It may be a game, maybe something really cool, but they didn't focus on what they were supposed to do. So often they got lost in the, I'm going to make something really cool, and didn't focus on what I need to actually do in order for my grade. So this task, I think, does a much better job for any student to look at and understand, oh, I have to do these things a little bit more than the older rubric. Not to say, I would say that I wasn't a great teacher that year for the task either, though, because the years after that, I did a much better job at making sure that they knew kind of the elements and what they needed to talk about when I was pre-teaching it. But that is one thing I like about this. Sasha, anything you want to bring up to us about this before we kind of give a pitch for why people should teach APCSP?
Yeah, I do have a couple questions. There are a couple interesting things that were brought up. So are there any other AP courses that have similar sort of similar tasks set up, or this is unique to CSP?
I don't know it off the top of my head, but one of the all I know about is one of the AP art courses has a similar kind of portfolio piece to it, which makes absolute sense, right? Student has to create some kind of artwork to be evaluated. And then there is, and I'm not a College Board fanboy that knows everything with College Board too, but I believe there's the AP Capstone course that also has a portfolio component to it. So those are the only ones that I know that are fairly similar to, that don't just have a traditional exam.
A lot of our kids at my STEM school are taking the AP seminar course as 10th graders. And we have an intro class that we require all of our intro to digital technology that we require all of our students take. But it's a lot of the stuff that we teach in that intro class is also covered in AP Computer Science Principles. So I finally convinced them that we're going to do an overlap of IDT and APCSP combined for 9th graders who are, that we know are advanced, that can handle it, so that those kids are going to get both those courses combined, and they'll have that APCS Principles portfolio experience as 9th graders, so that when they take the AP seminar as 10th graders, they're a little more familiar with how the College Board works and how the uploading to the digital portfolio, the deadlines, and I don't even know what they do as far as their seminar, but I just feel like having our kids do the principles class as 9th graders and having that exposure to the AP experience and the digital portfolio is going to definitely help those kids when they take the seminar class the next year. So.
And what are the challenges as far as plagiarism? Because I've been reading a lot about that for the create task. It seems like and I'm interested from one perspective, the sort of teacher side, but then also the actual College Board, what their process might be for that.
Joe, have you been a reader for the College Board before?
I have not been a reader.
I haven't either.
So if any readers are out there and you want to comment, that'd be great. But so from what I understand of the process is the first gate or firewall here is the teacher is supposed to report any indication of cheating. So the teacher can see the student submissions. Although we're not supposed to help the student at all with their submission, we can review the student submissions in which we're actually supposed to review them to ensure that there wasn't any plagiarism. And if we caught any plagiarism, to report that. An interesting thing this year is that the previous years, students needed to develop a piece of the code all on their own. So there needed to be something in the code that they made on their own where maybe they worked with somebody else. It was a team project, but something they had to own that and say, I really thought through this function, this procedure, and I developed this. This year, they don't have to. Technically speaking, and this is what I actually don't like this part of it. Technically speaking, the student doesn't have to demonstrate ownership of any of the code, as long as their team developed the code. So it can't be like, code they grabbed off the internet or anything like that. But they don't have to say, I made this one thing, or, my partner made that. Technically, someone could develop the whole thing as their partnership. But their written response has to be their own. They cannot collaborate on the written response at all. But that creates some issues. I think having it so that if students did work together, they had to own some part of the actual code, I think was a little bit better and kind of prevented, that urge to plagiarize more, to just kind of get your friend to kind of own more of this task than you. But but I don't know. We'll see.
You know, there's two sides to that too, because I have had some students where I've got, you know, a really, really smart student, or, you know, really good with coding, is helping another student who really kind of struggled. And, you know, I'm sitting here and they're, you know, in person, and I'm listening to them, and it was powerful watching these kids collaborate together. But this one kid was like trying to figure out how to write about it, because the one who knew how to do the code very well was not even going to let that kid look at his written responses. Like, he was adamant, you know, and it was beautiful because that kid had to understand that code so he could understand how to write about it. And so I wish I could have recorded the whole collaboration between the two, because I think that the stronger coder was able to really help that weaker coder learn more that he had not learned in the units prior. And I think he became a stronger coder now through it. So, you know, there's different ways to look at it, but I do have some that I know one person wrote the whole thing, and then they're just, you know, not really helping the other person know it. But yeah, that's what collaboration and teams is a lot about all throughout school and life. So you got, you know, some people who do a lot more, and it's just real life right there, right?
It is. I love how you pointed out exactly what in adult life also, when you're in a collaborative situation, it's what you make of it. So that person that didn't feel as confident in their programming skills was able to learn from that other individual because they wanted to. So that's really authentic and really valuable learning, and that's really how people learn. But you have to want to.
I see. And so, as far as results being sent back for plagiarism, yeah, that's probably not going to happen. Or
I was trying to remember where we started with this, but yeah, as far as the plagiarism, as teachers, I think we know our students really well by this time. And when you see a student who doesn't do well on multiple choice, doesn't do well on, you know, coding activities, and suddenly they're submitting some really powerful work, and you're like, some of it's not even stuff that we did in class at all. You know, I mean, yeah. It's amazing some of the stuff that's been submitted. So I've actually had to turn in 3 of them already. I've got 92 students. I've had to report 3 of them that I cannot let them submit what they were going to submit because I found it on the internet, and I've told their parents. So I've caught 3 easily just because I know my students, and it was an eye-opener when I saw that incredible work. But there's some that I don't know. I mean, it could be out there, but it's like, do I spend all my time trying to figure it out? Because the biggest thing is about the writing. I mean, if they can actually explain what's happening in their code, then, you know, it's I don't know that it's worth my time to sit there and chase down every single one to see if they plagiarized.
Last year, I did get 1 reported plagiarism from College Board. So I had a no score.
I didn't have that.
And so it was 1 student, but I really didn't have any other information other than that, just that it's a no score on my end. I asked my administrator that's in charge of working with College Board for the AP program, and they got from College Board that it was a plagiarism issue. But other than that, I don't know what was going on with that. And so yeah, I've had my instances just like Becky. One of my hopes is, this is for you, Sasha, is I'm hoping that now that I'm using coding rooms for my students to complete their tasks, is when you develop an awesome plagiarism detection tool, it will be a little bit easier for me to track those things.
Yeah, that's part of why I was interested to hear the responses on this. So yeah. Awesome. And then I don't know if this is in scope kind of for the current discussion, but what are the most common issues that our students are having? And we talked a lot about lists.
This is a great segue into our next section. So, Becky, yeah. What do you think? What other issues are you having?
Okay, well, I'm going to share it right now, actually, if that's possible. Let me see.
Yeah, wonderful.
Because I listed out some things today, actually. I can't tell what screen it is that I'm supposed to be sharing.
If there's anybody out there while Becky's looking that designs the video conferencing software, The usability of finding the screen to share, that could be something worked on, because I have that same, everybody does the same thing that happened to Becky just then.
Well, the thing was, is it was saying the one that I thought was right was screen 3, but normally on my setup it's screen 2. Yeah. And screen 2 and 3 right now kind of have similar things in them, so it was really confusing. Okay. Anyway, so here was my things that next year, when I get into the units, this was pretty much the last 2 units where you have functions and then when you have list. It is so important to make sure that students understand the difference between a user-defined procedure versus one that's already there, like, you know, on event. I have students that want to use on event as a procedure. I have students that that in Scratch, I have 2 students that are using Scratch because they did it in the IDT last year, and they insist on using Scratch, but they're using the procedures that are part of Scratch. I don't remember which ones they were, but they were not user defined, and that is something that has been a hard thing to realizing now that we're deep and almost done with all our submissions, that I did not realize these kids still didn't have that grasp. What is a user-defined procedure, and also where it is called. Where is the procedure called? Because they think that that first line, like in JavaScript, function, you know, evaluate, guess, whatever, they think that that line is where it's being called, but it, you know, parameter. I'm actually shocked how many of my students still at this point are not being able to, not using a parameter because they didn't quite understand what I meant by that. Like in our practice one, they were, we did a parameter, but then when I asked them to describe in their one that they're working on, because I have checkpoints in that 12 hours, I said, you know, what is your parameter and how are you using that parameter? And in those checkpoints, I don't give them, I don't like tell them what's right or wrong. It's just I want them to think about it. So like at hour 3 or something, they have to tell me what their parameter is. And I've had so many students at that hour 3 after doing like 3 different practice sessions and going over all the requirements. And then they finally get into their own and they go, what's a parameter? And I'm going, so I'm going to kind of relate that back to like algebra next year, I think, you know, talk about functions and how you have to put something in for X, or I don't know. Somehow I've got to make sure that I emphasize what a parameter is next year. And also, like on the calls, this is something we haven't talked about yet. At the last part of the written responses, this is a big one that people are having a hard time with, is explaining like 2 different types of calls. And they have to understand that it's a hypothetical. They think that they have to actually write those calls into their program. But it's just like a hypothetical type of call, but being able to explain what the if conditional is, you know, how it can produce different results based on, you know, if it, you know, what would make it be true, what would make it be false, you know, to come up with 2 different calls that would, you know, have it handled differently. And then let's see, declaring, initializing a list. Yeah, I think that part they know, but when I asked them in their checkpoints in the 12 hours to show me where they were declaring their list, they were not on the right track. They know how to do it, they just weren't able to show me where it was being done. And this is the big one, how to loop iterate through a list. Okay, so when students were trying to come up with ideas on how to do a list, they had these ideas, but and even though we did examples of all these, they didn't remember. And so it's like, I feel like I want to create like a some kind of an organization of different ways to handle a list, like how to just loop through a list by printing the values, how to access the values from you know, looping through the list, or how to compare the values, how to change the values, how to add elements. Compare, like if you have a user input, you want to compare, see if it's in a list. So I don't know, I want to come up with the different scenarios of like basic loops that you might need to use a list for, and have those as like a set, I don't know what you want to call it, like loop algorithms that are common for list. Does that make sense? Because I think that by doing that, it would give them more of an idea to know where to start when they're doing it because they just didn't seem to understand all those. But I would be glad to share this document. I just literally threw this together today, but this is, I went through and these are things that I use to introduce the task. We go through the scoring guidelines. We do some practice scoring of the samples. Jill Westerlund, who everybody knows is so wonderful, did this Waldo's Beach game, and so we use that as one, it was already written and the students could play around with it, and we use that just to learn how to do the written responses first. And then after that, we did one called Shopping List that is in Code HS. We did this task together. It comes in JavaScript or Python. I did both. I let my students choose either language this year, so I literally did both side by side all year long. I will not do that again.
I'd love to hear about that a little bit more in a bit. But.
Mostly because I thought that I might try to embrace Python because everybody thinks that Python is, the greatest thing. So I thought, okay, well, I'm going to try to embrace it. But I still want to get the option of JavaScript because it's more lean that way. But I've learned that even after doing this, I still don't like Python. So, and it was a lot of work.
Watch out, you got a Pythonista over here with me.
I know. So let's see. All right, so there's a Google template. I don't think I made it. It's out there. Anyway, I used them. I had them submit it to Google Classroom, and I used the Google Classroom's rubric feature that is great this year. And I made a 24-point rubric instead of the 6 points, so they could see exactly what things they were missing. So like in row 1, there might be 3 different things I was looking for, and so I broke it down into 24-point rubric, and I share that here just because I wanted to focus in on what part of that point did you not get. And then there's more examples that somebody named Calvin Studebaker, I'm not sure who that is, but his name is on this link. He's created some really wonderful examples, both in JavaScript and Python, that I found later. I would have probably have looked at those first and before I did the Waldos, but I didn't see them till later.
Before you move on to these other resources, Becky, how important do you think it was for your students to have that detailed of a practice performance task before the actual final one?
I don't think I did. I don't think it was great enough. I think I should have done more creativity on them, because this shopping list was very limited. And when it came to giving them that 12 hours to come up with something on their own, they shut down. It was the creative part was not there.
I think that's a hard thing. So I find one of the hardest things since AP Computer Science Principles started with this task specifically, especially not being able to help the students with the topic, you can't say you're going to do this topic. They really struggle to think of ideas. You have some kids that just think of something and they go right to it, and others that really struggle with finding what they want to do, or they have this anxiety about that it's not going to be good their idea, or it's not going to be able to meet the requirements, stuff like that. So I think it's important that you brought that up.
Yeah, and then the other part was just I have checkpoints during the 12 hours, and I actually make my students have to fill out a quick little 4-question document after like hour 1, hour 3, hour 6, just to let me know what they have, because if they can't answer those questions, then they're not making much progress. And I didn't give them feedback, but it was like, okay, all right, yeah, you're on track, you get the 100, And it also goes in the grade book, and the parents can see it. It's like, well, what are you doing? You're getting all these zeros at these checkpoints. What's going on? And I tell the students, like, it's an easy 100, guys. You just got to show me that you're on track, but I can't give you feedback. So
a lot of people have said the journaling or the diary type entries throughout it is very, very helpful.
Yeah, and we are trying to get STEM certified, so we have journals that they have to do for the STEM certification, and so I've also been telling them to put that in their STEM journal too. Yeah. But that's pretty much all that I had in this document. But my biggest things were in the beginning. Next year, there are certain things about procedures and lists that I have to emphasize better in the beginning, so that when we hit that those written responses, they know how to answer those things better.
Yeah, so definitely. So to go back to that, one of the big things that a lot of people talked about were those event handler, you know what I mean, these other kind of function definitions or procedural definitions that were either part of whatever framework was being used, or if it was a blocks language or blocks coding environment, they, you know what I mean, that has these, a lot of them have event handlers, App Inventor, Microsoft's Make Code, etc. They have these event handlers that those don't count. So even in, with JavaScript, some of those handlers, those don't count. This had to be a student-developed procedure. The name had to be student-developed. The parameters for it had to be student-developed, and the algorithm within it. So that was definitely a big thing that was debated about what counts, because especially when you're defining something that's going to be essentially an event listener, event handler, the code inside of it is all yours. That's your algorithm for what you want to happen. It has probably different calls each time that it's called. There's some different things that can happen, but College Board listed it as something that doesn't count. And this was a big debated thing. So you brought that up. Did that come up often with students, that they were just confused by that point, not understanding why they couldn't use something like that?
The only ones that I think had the trouble with it were the ones who were trying to use Scratch, because they had familiar with it before, and they were trying to use like when the sprite is clicked as their function or something like that. And yeah, because I don't think that when we did Scratch in the intro course, I don't even think that we ever created our own functions in Scratch. So yeah, and I mean, I don't know why those kids chose to go that route, because I think it actually made it harder for them, because we didn't use list in that intro class either. So they were having to teach themselves things in Scratch that we didn't do before. Anyway, but I know that like in the in code.org's app lab, they have the event handlers that I've seen, and but we didn't use.
That's where a lot of
Yeah, so I didn't see a lot of my students do that, because we used CodeHS, and we just, there was probably only 2 lessons where we actually used event handlers. So a lot of mine didn't know about that. Yeah.
Sasha, anything come up on your end while we were having that conversation before I kind of like to close with one thing from Becky, just to get this idea from her.
Sure thing. No, I'm good. I think it might be interesting at the end, before we wrap up, to mention kind of positioning CSP, as a new course in many schools, but that's kind of a bit off topic. So I'll pass it back to you, Joe.
Yeah, so yeah, let's bring that up next after this. So Becky, you absolutely intrigued me, and me and you have talked about this just briefly through Facebook interactions or something. It blows my mind that you chose to do Python and JavaScript in parallel like that. So I do have conversations randomly with people trying to do some crazy ideas. There's some people out there that I know are on these Facebook groups that tried to do React Native and some other things as part of their APCSP curriculum that seem like really cool ideas, and then when you dig into it, all of a sudden you're like, why did I go this complex? But students can create some really cool stuff. But so yours is really interesting, because students get to choose a language. Just talk through that a little bit more. I know you said you're probably not going to do it next year. Just let us know, what was the experience like, just in case someone else is thinking about those wild ideas.
Well, I mean, the idea came because CodeHS, offered 2 versions, and I thought, well, that's cool, and they align very well. So I mean, they were doing the same programs back to back, all the way throughout, and so it was just something that I was like, I really like JavaScript, don't want to let it go, but so many people want to learn Python. Let me just see if maybe I can do both. And plus, I didn't know Python, so I was going to have to learn it along with the students. But once you know a language, you can learn another easily, right? So, but it's a lot different. So there was a lot of learning curve there for me with Python. Anyway, I gave my students some things to think about, and I'd have a document somewhere that I had shared with them at the beginning of the year. And I said, this is some of the things that Python's more commonly used in, and this is what JavaScript would be used in. And I said, and JavaScript is a little bit more similar to what, if you want to continue and take Java with me, or web development, you probably want to learn JavaScript. I had, out of the 92, I had 70 that chose JavaScript, 22 that chose Python. I did say that what I hear is that Python is usually a easier language to learn for beginners. Not so
Very
much,
highly debated.
Not so much for somebody who is, learned on Pascal and Basic and C++ and Java. Python was a lot different for me. But I don't know. To me, it was feasible. I mean, if you're familiar with the course and you're good with coding, you could easily do it. I definitely felt like I was having to do a lot more support for different people at different times. I don't know.
I would think without like a truly good flipped or asynchronous type of, which CodeHS's curriculum helped provide you with, right? Without that, it becomes really difficult, right? If you're trying to just do live teaching all the time of it and dual languages, I can see that being really difficult. That's one of the cool things about CS is that we can create kind of these interactive textbooks, interactive pages, videos, and students could kind of self-pace through and have a lot more choice.
Yeah. I mean, in hindsight, honestly, I can't say that it was difficult. I mean, I'm pretty comfortable with coding, and I'm easily able to troubleshoot. I mean, my students say they're having trouble with one. I'm like, all giddy, like, oh yes, let's go troubleshoot. I love it, even if it is Python. And so I don't think it was a lot to add into my year, but I just really want to have all my kids on the same page next time. And plus, I'm going to be teaching web development next year, so I'm creating a whole brand new course that nobody else is teaching that I can find. So I don't need more on my plate while I'm trying to create a new course.
Yeah, absolutely.
I'm really curious to know both of these languages, JavaScript, Python, and I'm sure Scratch, just to probably even to a greater extent, really skip over this notion of data types in a real meaningful way, right? They kind of abstract that away from each from the code that students probably be reading and writing for the most part. Positive, negative, no factor.
I'm not sure what you were questioning there.
So often in those other languages, students don't have to worry about the fact if they're dealing with an int or a floating point or a string. So I actually have some interesting things. I think my Python curriculum does a pretty good job that when my students go over to Java, like, it's not like, what do you mean data types? Like, we focus on data types fairly early on with some of the different operations that they have to do. So I always find this interesting. And for any of those watching, one of our podcasts coming up is going to be, it's a ways away, but we're going to talk about first programming languages. And hopefully we'll have a panel of, what language should students learn first? And I think we'll have a panel of very interesting people from university all the way down to middle school about their thoughts on this stuff. And people get really opinionated about this topic, so that's going to be a good one. Especially, everyone's always against Python in this community, and then you have me that loves Python. But so I'll be curious about that. But yeah, it certainly can be a sticky situation. I think if you don't talk about data types at all, you can have issues later on where students don't even think of that's a thing. Even when I've taught the block environments, I tend to talk about data types still. So it's interesting.
One of the things that it was funny this year is when I would be teaching the JavaScript kids how to do a for loop, and I would always type for int I equals 0, and I can't tell you how many times that it would bug out and I couldn't figure out what was wrong. And my students were like, well, Ms. Fisher, you wrote int, didn't this be var? And I'm like, oh, yeah. Because I mean, I do Java too, so. Yeah.
Believe me, it happens even with, so those two, much more similar structure for your for loop there. With Python and Java, it's different, but yet still I'll be in front of them, and because just last period I was doing something in Python, then all of a sudden I'm in Java and I go to type and it's like Python, I go, or vice versa. So it happens.
Yeah, the colons in Python, I kept forgetting to put those colons too.
Yeah. So yeah, it's interesting stuff.
Yeah.
So Sasha, to close out, I think you had why should schools offer AP-CSP and then track? You know what I mean? What are the progressions? Is that what you were thinking about?
Yes, I'm really curious about that. Specifically for schools that don't have a real, I hesitate to use the term real, but sort of a more meaningful programming course, right? And I think even though CSP is very high level, it does involve quite a bit of hands-on programming, as opposed to, for example, some of the other like GCSE curricula that are really focused on. I mean, they'll talk about hex and binary and go into assembly, but won't touch that much on actually writing code. So I think that's really interesting. But is there some kind of optimal rollout strategy of like starting with an intro course, then doing CSP, then doing CSA? Can you kind of roll those out incrementally? How have you been finding CSP as a sort of step towards CSA for students, maybe even for instructors who are new to teaching CS? I mean, there are so many different angles for this question. And even today, just now, I think I saw on one of the groups that someone was asking, should we bring back CSB? Or what was formerly, I think, CSAB, which
data structures.
Yeah, it's probably at least a decade off now. I mean, it hasn't been around for at least about a decade.
There was a conversation, I think it was just yesterday, and it's actually two teachers with my county, or actually Crystal Furman, she used to be in our county, but she's now at the College Board. And but they were talking about why did we get rid of AB? And this was prior to, I don't even know if I was teaching at the time, but and they were talking about data structures, and I guess it just wasn't popular. Maybe I think it was that it just wasn't. I don't know. It just wasn't something that was being taken by students. But now I feel like we need more. These students, they need to learn those data structures. They need to learn like what a real back end, data looks like, and for an application. I mean, it's not just about typing something in and something coming out. It's, you got to learn about how to store this stuff and how to access what's being stored. And I mean, I don't know what was all in the other one, but I feel like because of where we're moving with computer science and it becoming so popular, I feel like it honestly it's going to end up being a core course, not necessarily programming, but just the computer, the basic overall about computers, the principles basically. I think it needs to be taught from kindergarten all the way through, because students need to know how a computer works, how software works, how the internet works. Those are things that everybody, I think, should know. And, so I'm a big proponent of CS for all. Now, as far as the advanced programming, no, not everybody needs to know that, but at least if they get that introduction, they get that principles course, then they decide whether or not they want to go further with it. And bringing back that the AB course, I think it needs to come back, because I think that kids are getting more computer science at an earlier age now, and I think there would be a lot more interest in it in high school. Just to backtrack, my son, actually, he's going to be 27th this month. He went to Georgia Southern and majored in computer science. When he left high school, he had never wrote even a hello world statement. He never tried one line of code in high school. But because of my background, I convinced him, because he graduated in 2012, so I was still teaching math back then. And I convinced him, I said, maybe you should explore computer science. So he went to Georgia Southern and majored in computer science. Didn't have a lick of code before he went to college. He did an internship with AT&T, ended up getting hired there, but he said he was working with kids that were over at Georgia Tech. And he just felt like, Mom, I just don't feel worthy with these kids. And I'm like, but I look at him now, and he is a great programmer. He's doing really well for himself at 26 years old. And he didn't have it in high school. And you just imagine these kids that are now getting all this stuff in high school and the opportunities that are out there for them, the more that they are able to get from us. So, and I'm willing to do that. I just don't know that we have a lot of teachers who are. So that's the other issue.
So my students always say, you know, when they go to university and they come back and they're talking to me, oh my God, I didn't know how much I knew. I was in class with a bunch of my friends, never programmed before, and they're in this class. Like they help, you know, they're always helping, you know, their classmates out because they have some experiences. But so often it's hard for us that are deep into it to realize that there are still students that aren't being exposed to this.
Yes.
Even today, we've expanded it greatly. And so because we've expanded it greatly, I think the day's gonna come soon that we are gonna start to talk about bringing back AB. But I will say, I think we have some more work to do, because if we look at the numbers, we've expanded AP Computer Science Principles, which was mainly what we're talking about. We've expanded that greatly, and there's tons of students taking that. We've done a really good job. But the A numbers still haven't gone up as much as we would like with creating kind of a nice pathway to Computer Science A. I think someone like, you know, at my school, and I think Becky, you know, we've created that, but there are a number of schools that I know of, just neighbors to me and other people, that are still just teaching AP Computer Science Principles. And it may be that a teacher is still new to computer science, teaching computer science, they don't feel comfortable with A. I'm hoping that, my hope is that code.org now releasing AP Computer Science A and having a curriculum to support that. A lot of those code.org users and teachers will jump on AP Computer Science A, will bolster that community, will bolster, you know, how many students are really taking that, and hopefully we'll be able to have a day where we want another AP Computer Science course and we want to bring back AB.
Yeah, there's still a lot of schools that are still not offering principles. The school that I went to years ago, we didn't have it. I was trying to get it pushed into the school, but it's a small school in a rural area, and there just wasn't a lot of interest. But this job opening happened, and so I left there, and I don't think they have anybody that's willing to push it still. So
we have some schools, there are probably some of you that are watching the live stream right now, you only offer CSA. And I would hope that this may be, you know, conversations convinced you, hey, you know, it's worth using it. Even if you have an intro class, use APCSP instead for it. I think it's a nice stepping stone in a great way. Another great course you can offer. Some schools, though, only have room for maybe APCSA, or don't even have room for computer science. And so that's another struggle.
One interesting point, I'll maybe this can be one of our last points, and if any of you all in the live stream have questions, please drop it in on any of the groups where this got posted. I personally self-studied for APCSA, and I'm just recently was reading about some folks doing the same thing for, I think, for CSA. Perhaps it's more common there, but what do you all think, especially at schools that may not have a sort of local in the sense that their school teaches comp sci? What might be some ways to help those students like still get more meaningful access to this kind of teaching? Is there a way for local schools to kind of offer a route for students to self-study maybe like zoom into local districts or other schools in the district that have have these courses already?
So Becky, I'm curious about your, from your perspective, but I will say I'm fairly proud about my state, Rhode Island. They've made national news about the computer science movement here. And one of the great things that we did create within the past couple years is this advanced course network, they call it. And it's not just for computer science, although that is one of the largest components to it, but school districts can put some of their courses or can offer some of their courses as part of the advanced course network. We have a number of computer science courses that are offered through it, and students that go to other schools can enroll in those courses, and they're online, they can be hybrid. There's a number of ways that they can be offered. And we also have community organizations that offer courses through it, as well as some of the universities offer high school students courses through this advanced course network, and it's free. The state pays for it, so it's free for students to enroll, and they can participate in other courses. So if for whatever reason their school does not have a certain computer science course, AP Computer Science A, a student still has access to a teacher teaching it. Of course, they can self-study, but they can enroll in one of these courses.
Yes, and we have the same thing here in Georgia, and we actually do have students that at my former school that would take AP Computer Science Principles or AP Computer Science A with Georgia Virtual School. It is state funded, and it is if it's not offered at that school, that student can take like a class period where they're doing that course. They might go in the media center and work on it or something. That is offered. That is definitely an option. As far as though, like, I feel like the question was more about how to get the schools to, how do we get these schools to like try to, promote it and, offer it to the students. I mean, you're asking these students that are like, they want to do it and they're going to take that initiative, but I feel like the schools themselves even need to try to kind of get these kids exposed to it as well.
Yeah, absolutely. The struggle is always budget, depending on the number of students, recruiting strategy. So I don't know, Becky, if you've had certain luck with certain recruiting strategies. I always have great numbers, and we're one of the highest enrolled programs at my current technical school. I'm not sure what it is other than happy, positive attitude, and showing students that they can do really cool things that they interact with all the time. So we do have this exploratory rotation through all the programs at my school. So it does give all of us an opportunity to advertise to every student that enrolls at Davies Current Technical High School. Not every school has that opportunity. But do you have any course fairs? I've seen that at schools and stuff like that.
Yeah, we do have we do have what do we call it? We have some kind of like fair every year that we have students. We set up tables in the commons area, and students can come and talk to all the different CTE teachers to see what we offer, and not just CTE. I mean, the foreign languages, the arts, and band, all that stuff. But we one of my big pushes, and right before I left my former school, and I got this opportunity to come to this STEM school, I was really trying to get it pushed. But the thing was, they were going to let me teach it. I was a math teacher, but they were going to let me teach it if I had the numbers. And we didn't have the numbers that year. But but right before I left, I think I was actually going to be able to teach. I had a lot of kids pumped up because I started in December going around telling them, hey, it can count as your fourth science in the state of Georgia, or like the public universities in Georgia would accept it as a fourth science, or if you took 2 coding courses, programming courses, it could count as your 2 foreign languages. As far as the colleges, now for high school graduation credit, it could also count as math, but the colleges didn't accept it for math. But the tricky thing about that was that, I was going around telling these kids this, and the counselor's like, oh my God, what are you telling these kids? And I'm like, well, I've done the research. But the thing is, you have to make sure the kids know, like, where are you wanting to go to school? Because if you want to go out of state, you need to look at that state's requirements. If you want to go to a private university in Georgia, you still need to look at what they want, because this was only what I knew of that the Georgia public universities would accept. So that was a big selling point. And I think that before I left that school, I had a lot of kids with their hopes up that they were going to take computer science with me. And because of those reasons, well, some of those reasons, but then this job, this door opened. I wasn't even looking for it. This door opened. And so I came to the STEM school. And now at this STEM school, every 9th grader that comes in has to take our intro class. And that is a big way to, get them exposed. So,
yeah.
And like I said, I think that every high school needs to be offering at least an intro computer science class, at least.
I'm with you. So based off of what you said, Sasha, I have one for a podcast of the future. CS courses counting for math, science, or foreign language. That's also a hot topic that we'll definitely get some excitement from. So
I'm disappointed that it can't count as a math because I feel like it's more math related than it is science.
Some states they do. Some states they do.
Right, but in Georgia, it can only count for high school graduation, but not for the colleges. So.
Yeah, so it's a very interesting topic. It's tough because it's a double-edged sword when you substitute kind of computer science or something else. Then you're missing out on something else that's often a requirement. So it's like it's a weird thing.
We do have several of our students that do it as their 4th science because they're burned out on their sciences and they're like, they take APCSP. I have seniors that are taking APCSP as their 4th science, and it's much easier than the other options they had.
I will say that I see APCSP counting as a 4th science or something like that. If you've already taken bio, chem, and physics, APCSP I think is a cool 4th science credit. I would be okay with that. So that's interesting.
Yeah.
All right. I don't see any comments, Sasha. Do you see any comments from anybody? Questions?
No, I think that's it. I think that means we very thoroughly covered everything.
That's what I like to think.
Awesome. So I think with that, I'd like to thank you all, Joe, Becky, for taking the time creating the resources. This recording will be posted on YouTube as well with the resources too. So I hope this helps even more people who weren't able to make it to the entire live stream. And we'll continue to monitor the comments after the stream as well. So thank you all for watching and hope to see you again on our next live stream. Thank you.
Thanks.
Bye.
Bye, everyone.
Bye-bye.
Bye.